right, so today we're going to talk about, or start to talk about, what statistics are. So statistics is the study of data and the individual pieces of data. And the purpose of statistics is that it has many uses. Perhaps the most important one is to help us make good decisions about issues that involve uncertainty. We study statistics so we can make better informed decisions. So if I was a student in this class and I'm looking at, there's going to be exams over this stuff, I want you to understand you're going to need to understand the vocabulary. I will not have you write out the definitions, but you're going to maybe have a little matching or fill in the blanks with the definitions. And this first test will have a lot of definitions. So start to make some notes of understanding what these are. I've created some activities, and you'll also have some homework that'll help you understand these words a little bit better. But there might be some things in these, and I've tried to group the vocabulary as much as I can in the beginning of the section so that you can study them easily. But you will need to know what the definitions are. And if I was a student, I might make note that the most important purpose is to help us make good decisions about issues that involve uncertainty. That sounds kind of important. So kind of pay attention to things like that. All right, so raw data is the actual measurements or observations collected from the sample. And then the data is the numbers or other pieces of information. So they use the raw data to create the data, and out of our whole thing, we will pull a sample. That's the subset of the population from which the data are obtained. Now, for your sample size, how many do you need? Well, you need enough participants in the study, so the study represents the entire group or population. So if we're talking about like all Americans or a big group, you can't have 100 people surveyed if you're looking at representing the whole country. If we're just looking at Texas, you would need enough people in the state of Texas to represent the entire state. It's a big state. It's not a small state. You would have to have some people from the big city. You'd have to have some people from the rural part, maybe some that live down at the beaches. You have to have it representative. The sample statistics will be the data that is analyzed from the sample, and then use the data sample statistics to infer things about my population parameter. Now, the population will be the complete set of people or things being studied, and those parameters are specific characteristics of the population. Like if we were looking at our class, and in a statistics class at A&M Commerce, what is their favorite color? Or what is their favorite restaurant? Or what is their favorite type of food? There's lots of things that we can focus in, but you're looking at a specific characteristic that you're studying. Now, there will be margins of error, and it's used to describe the range of values, or our confidence interval, likely contain the population parameter. We will find the confidence interval by adding and subtracting the margin of error from the sample statistic obtained in the study. So it'll be the sample statistic minus the margin of error, and it'll go all the way up to the sample statistic plus the margin of error. The confidence interval is the range of values which are likely to contain the population parameter. So we'll have that percent that we find. Our population parameter will be in there, and then the percent at the end. So the margin of error is generally smaller for larger samples. However, it's possible to get meaningful results from surprisingly small samples. It just depends on what you're studying, and it depends on what all is going on, and if you've got a representative sample or not. And the reason that it's the larger the sample you have, then the more likely it is to typically give you more of what you're expecting to see. If you have a small sample size and it's not very representative, then you'll have more errors there. So if a sample is truly representative of the population, then what is true for the sample will also be true for the population. So if in our statistics class we looked at, let's say the favorite color is blue, and if we have a truly representative sample in our class, then it would be able to apply that and say for the campus, the favorite color is blue. But you have to make sure you've got a representative sample, and we will get more into that as we go. All right, so you just really need to kind of look at these words. If it seems like a lot of words, it is, but we're going to use those throughout everything that you do. All right, so let's go do an example. We have an unemployment survey. The U.S. Labor Department defines the civilian labor force as all those people who are either employed or actively seeking employment. Each month, the Labor Department reports the unemployment rate, which is the percentage of people actively seeking employment within the entire civilian labor force. To determine the unemployment rate, the Labor Department surveyed 60,000 households. For the unemployment reports, we want to describe 5 things. We want to describe the population. We want to describe the sample, the raw data, the sample statistics, and the population parameters. So we've got our problem here. Make sure you can still see the problem while let me adjust the angle here so I can write, while we're working on what we understand. So you've got the problem here. And if you're in my class, you'll also find this handout in week 1, and you can print it off if you're online during the summer time or perhaps at other times. But you can find it there. You can print it off, or you can just open it up so that you have it available while I'm teaching the lessons or when you're doing homework. Or if you're trying to, study those not spelling words, but vocabulary words. All right. So this is section 1.1. We're on example 1. And we are looking at part A. We want to figure out what the population is. So remember from our vocabulary at the top of our handout here, it says that the population is the complete set of people or things being studied. Well, what is the labor force studying? Well, if they're looking at the unemployment rate, right? So they're looking about the people who are making up the civilian labor force. So there reports the unemployment rate, which is the percentage of people actively seeking employment within the entire civilian labor force. So our population for this problem is the group got to stay on the screen. The group that the Labor Department wants to learn about. Which is all the people who make up the civilian labor force. Oops. All right. So that's our population. The next word we need to find is our sample. So if we go back to our vocabulary words, our sample is a subset of the population from which the data are obtained. So our sample so the sample consists of all the people among the 60,000 households surveyed. All right, whoops, we're out of the screen. We're going to have to switch up a little bit so we don't get out of there. All right, so the sample is the 60,000, they surveyed 60,000 households. So that's what our sample is those 60,000 households out of the entire U.S. All right, next one, part C. Part C is what is the raw data? Raw data, you can say it either way. So for the raw data, it consists of all the information collected in the survey. So what does that mean? Well, those are the answers. When they surveyed those 60,000 households, they got answers, right, to their questions. And that answers to those questions are the raw data. All right, part D. Part D is going to be the sample statistics. So if we recall from our definition, the sample statistics is the data that is analyzed from the sample. We use the data sample statistics to infer things about my population parameter. And the parameter is that specific characteristic of the population that you're looking at. So for our sample statistics, we're going to, it'll summarize the data. Now let's see. The sample statistic summarize the raw data for the sample. In this case, the relevant sample statistic is the percentage of people in the sample who are actively seeking employment. All right, so let's go figure out where that came from. Each month, the Labor Department reports the unemployment rate, which is the percentage of people actively seeking employment within the entire civilian labor force. So the answers I want you to see are coming straight out of the questions or the actual problem. All right, our next piece is our population parameter. So for our population parameter, we actually have an S there. So for the population parameters, remember that those are the specific characteristic of the population. So, and and they're going to correspond to our sample statistics. So in this case, the relevant population parameter is the actual employment rate. So that's what they're looking for. The specific characteristic, they want to know what the unemployment rate is, or the employment rate. And I left off the N, so sorry. The unemployment rate makes a difference, right? They want to know who's unemployed and what are they looking for. All right, so the next part we're going to look at is the basic steps in a statistical study. I'm going to actually bring up a bigger diagram that we can look at. So in a basic steps in a statistical study, we're going to state the goals of our study precisely. So it's got to be very clear what your goals are. And that is determine the population you want to study and exactly what you'd like to learn about them. So like in the previous problem, they were studying the people actively seeking employment, and they wanted to know, what the unemployment rate is. Second, we're going to choose a representative sample from the population. The next one, we're going to collect our raw data from the sample and then summarize the findings by finding the sample statistics of interest. And then we'll use the sample statistics to make inferences, infer things about the population, and then we'll draw some conclusions and determine what we've learned and whether you achieved your goal. So we'll start out, we'll identify our goals about our population, we'll choose a representative sample, we'll collect some raw data in that case, then look at the sample statistics so that we can infer things about our population, which would be our population parameters about the characteristics we're looking at, and then we'll draw conclusions about our population. All right, so let's go look at an example. So we're going to identify how researchers applied the 5 basic steps in the case study, the Salk polio vaccine. So in 1954, a large experiment was conducted to test the effectiveness of a new vaccine created by Dr. Jonas Salk. It involved a sample of 400,000 children chosen from the population of all the children in the United States. Half received an injection of the Salk vaccine, and the other half received an injection that contained only salt water, which we will learn is going to be called a placebo. That way everybody in the experiment gets some kind of treatment in this case so that they don't know who got the injection of the vaccine and who got the salt water. So among those that received the vaccine, only 33 contracted polio. But there were 115 cases of polio among those who did not get the vaccine. Using the techniques of statistical science that we'll study later, the researchers concluded that the vaccine was effective at preventing polio. So we want to take this information and we want to follow the steps. Okay, so the first step was the goal of the study. So this will be example 2. So what was the goal of our study? Well, this was to test the effectiveness of a new vaccine for polio. That was the goal. Okay, the next thing is to look at our population. So who was the population in our study? Well, in this case, it was children, but we have to be specific because it was of all the children in the United States. So we need to put children Oh, I keep forgetting to change colors. So sorry. It makes it easier if you're looking back. Children of the United States, because that's where he was conducting the study. All right, the next thing we want to know is, what was the sample? Well, if we look back into our summary of the study, we can see that it involved a sample of 400,000 children. Now, again, we've got to be clear that it's 400,000 children in the United States, because it's not children from any place, because this is how it was. This is where they did the study. All right, and then the next thing, once we found our sample, we need to do the sample statistics. So, in the sample statistics, remember, we're going to analyze the data that we got. So we're going to use the raw data of how many children in the study got the polio after the injections to summarize the effectiveness of the vaccine. So we had 400,000 children that got it, and it said half received an injection of vaccine and half received an injection that contained salt water. Those who got the vaccine, there's 33 of them. So that's 33,000, or 33. So let's put the vaccine. So for the vaccine, we had 33 out of 200,000. And that'll get us a decimal of 0.000165, which is I'm going to move that decimal place over 2 places, or you can also multiply by 100. 0.00165%. We're going to put it in a percentage. Percent of the children who got the vaccine got polio. All right. Now, let's look at our salt water. So out of the salt water, we had 115 cases. So 115 out of 200,000 will get us 0.000575, which again, if we move that decimal place, oh, I totally did it backwards up here. I'm so sorry. All right, we're not going to move the zeros there. We're going to move the zeros here. So sorry. I'm used to the zeros being so much closer. So we stopped our decimal place there. I don't know what I was thinking. You're like, what is she doing? So sorry. This is why we give partial credit, because we make mistakes. I'm juggling and looking at the document camera and the screen to make sure I stay in there, and going back and forth the lesson plan. So sorry. So 0. We have 1 0 left this time. 0.575. And then let's go up here, because I just realized. All right, so this is, I moved it 0. There should be only 1 0. All right, so we will move this out of here. So 0.0165%. So sorry. All right, so these are the ones that got the salt water. Now, when we look at this, this is 0.0165. So 0.01% versus 0.05%. So this is, it's quite a bit more. So let's go kind of compare the number of vaccine to the number who got the salt water. So let's do a little bit more statistics data on here. So we have 33 who got the vaccine that got it, and 115 that had the salt water. So we're just going to do a comparison. If we do that, we get 0.28695622. We don't need that many decimals. And again, we're going to move that decimal place 2 places. Will get us 28.7 because our 6 will round up because the 9 is going to round to a 7. And if we even wanted to do to 2 places, the 5 will cause the 9 to round up, which will cause the 7. So 28.70%, we'll put in that 0 just for a little significance there. And if we look at this, we can look at that. This is only 28% out of this one, so about a third, right? About a third of the student or the children got it in this one versus that one. If we flip this over, or we can even, let's do a little bit more with this data. So if we took this 28.70, which means we take 100% minus our 28.70%, we are given 71.30% more children got polio with the salt water. Than with the vaccine. So 71.30% more children got polio. That's a big chunk. All right, now let's flip our numbers here. And if we take 115 divided by 33, we get 3.4848, which will get us 3.5, because the 8 will round the 4. 3.5 times as many children got polio with salt water than with the vaccine. So that's huge. So we can take this data and we can do lots of things with it. This is huge that 3.5 times as many children still got the polio. That's a lot. So that's where they were able to infer, based on our sample statistics, to the, like, hey, this is actually really effective and we need to do something about this. All right, our next, and give everybody the vaccine. Our next part is our population parameter. So for this one, so remember, the population parameter are the specific characteristics of the population. So we were kind of looking at that. He was looking at the vaccine. This is what they saw in the short term. But we don't actually know these in the time because when they were doing the study, because you're going to have to wait for the future. In the future, they would learn more about the effectiveness of the vaccine once it was given to the entire population. And but they could use the sample statistics, like I said, to infer that it was being very effective, and that on the entire population of the children as it was in the study. But we don't know this. At the time that they're doing the study, they're going to have to do it. It's just kind of like today in the vaccine for the coronavirus, for COVID-19, they're going to have to wait a while for that for all the data to come in and see what the effectiveness of the vaccine truly was, and any of the side effects that they've seen, like how much they really affect the population or not. There'd be a lot of study that will be done during this time and for the next several years on the pandemic that we have encountered. So, like I said, we don't know these at the time. We know it now. But at the time of the study, we don't know these now, but will in the future. as we learn more about the effectiveness I dotted my I too soon, sorry. The effectiveness of the vaccine once it is given to the entire population. But like I said, they can use the sample statistics. So, however, we can use the sample statistics to infer the vaccine effectiveness on the entire population. So what they expect to happen is that it was so effective in the group, it should be very effective on the population. On the entire population of children, as it was in the study. All right. So, and I apologize for my handwriting. I do not have the best handwriting ever. You can always back it up on the video to, like, what did she say? I just want to make sure I don't just talk about stuff, but I actually write stuff down for you. All right, so the last step in our study is to draw the conclusions about what we have figured out. So we're going to draw some conclusions. The conclusions, now since our sample statistics showed that the vaccine was significantly more effective than the salt water, the researchers concluded that the vaccine was effective at preventing polio. Now, on the population, they still had to wait and see, but this is the conclusion that they drew. Is that since the sample statistic showed that the vaccine was significantly more effective than the saltwater injection. Researchers concluded that the vaccine was effective at preventing polio. And it was, because you don't hear much about polio cases anymore. It was pretty much wiped out through the vaccine, and children are still given that polio vaccine today, except now it's even done in oral form. Like, it doesn't even have to be one of the mini shots that you get. All right, let's go on to our next example. So our next example is, does it make sense? So we have a poll conducted 2 months before a presidential election, and that predicted that the Republican candidate would win with 55% of the vote. The survey had a margin of error of 3 percentage points, and the Republican candidate lost the election. So the poll said, hey, they're going to win for sure with 55% of the vote. So what does that mean? And does it make sense? Well, it does make sense. So for example 3, it makes sense, first of all. The margin of error suggests that we had a margin of error of 3 percentage points, right? And we're assuming that they're saying it's 95%, because typically that's what we're looking at is when they say that, it's going to be a 95% accuracy for that confidence interval. So remember we talked about the margin of error is going to be our sample statistics plus or minus that margin of error. So if we take 55% minus 3%, we will end up with 52%. And if we take 55% plus 3%, we get 58%. So we're saying that the confidence interval is 52% to 58%. Now, that's still pretty close to 50%. It doesn't say how much they lost by, but 50%, that's like half the people, right? It's pretty close. So there's always some chance that the population proportion is outside of this confidence interval. It could have been outside. And in this case, it would not need to be far outside for them to lose because it's so close. So when they did that poll, how well was their poll, right? Was it really representative of the population? And also, it was taken 2 months before, so 2 months before the election. You know, during those 2 months, some things might have come up, some things might have happened, and the voters could have changed their minds. So it's 2 months outside the range, right? It's 2 months outside from the election, from the poll. And this is still so close, right? 52%, that's one of those nail biters. It's not like they were saying, hey, they're going to win by 90%. Because then you're like, well, then we would have thought, well, surely you didn't have a good population sample. So definitely not going to win. So let me give you some clue words here. So we have population proportion is outside the confidence interval. So that could have been one of the reasons. And then the other thing that could have happened was that the poll was taken 2 months before the election. So voters may have changed their minds. All right, next question. So the producer of a new song surveys 1,000 consumers and finds that most of them are very enthusiastic about it. So she convinces the Sony recording company to promote the song. Does this make sense? Well, it does make sense. The producer of the new song, they surveyed 1,000 consumers. That's a lot of people. And find that most of them were enthusiastic about it, so it makes sense that she would say, hey, they're excited about the new song. So what does that, I think we should do that. Remember that the purpose of statistics is to help with decision making. And the survey was conducted well. It is possible to draw conclusions with a high confidence from a survey of 1,000-person sample. So remember, the main thing about statistics is to help us make decisions. So the purpose of statistics, remember I told you, hey, you might want to take note of that, is to help with decision making. With decision making. All All right. They had 1,000 people, so that's a pretty good sample. So 1,000 people. Is a good one, right? And they interviewed consumers, right? They didn't interview people who are not consumers. And if the survey results indicate that most people like the song, it makes sense to promote it, right? So even though there's no guarantee that the promotion will be successful, if the people in the survey liked it, it's probably going to do well. All right. People in survey liked song. So it should sell. All right. Nowadays, I mean, a lot of it's electronic download, so they don't have to invest as much into the actual physical parts, like, having them on the shelf. All right. So example 5, identify the sample, the population, the sample statistic, and the population parameter. So for 186 randomly selected babies, the average or mean of their birth weights is 103 grams. This was based on a study that was done. All right, so this is example 5. This is our last example. So we want to identify the sample. We want to identify the population, the sample statistic, and our population parameter. All right, I know you can't see, there we go, they're all in there now. All right, so what's our sample? For 186 randomly selected babies, that were the ones were selected. So our sample is going to be the 186, babies that were selected. The population, well, if we're selecting babies, then the population's going to be the complete set of babies. And that complete set's kind of important. Instead of just saying it's babies, you want to include the complete set of babies because they're looking at everybody's babies. That way it's understood. All right, the sample statistic, the average mean of their birth weight is 3,103 grams, so 3,103 grams. That is our statistic. And the population parameter. So it's still, again, not known, right? We don't know exactly what the population parameter is that they're looking for. It's not known. However, or the value of it is not known, right? So if we're looking for the value, we don't know, not known for the value, right? I got value out of there. It should have been the value not known. But the average birth weight, but it is the average, and average we will learn is the same thing as the mean birth weight of all babies. So they got that from our sample, right? Our sample was the 186 babies. Out of those, their average birth rate was 3,103 grams. And so we can infer that onto our population, that the average birth weight for all babies is probably this, but we don't know for sure. I mean, 186 babies is not a lot of babies for the entire population, right? So they'd have to do some more studies to see if that really applied to the population as a whole, and maybe do some bigger groups, and you have to make sure it represents the entire population. All right, so this is the end of 1.1. You need to make sure you do your homework for 1.1. You'll find that in our D2L as well. And there will also be an activity that you'll do. And you'll submit homework and your activities into the folders that match. So one is going to be like 1.1 homework, and one will say interpret a survey folder. So the survey that you'll be doing is something like this, where you're working out all the pieces and parts out of this one, just like we just did. It'll have more to it. And then make sure you get those things submitted, and also look out for quizzes. There might be some quizzes that help you with the learning of vocabulary in that. So be looking, and you can use your handouts to work on those, to do the quizzes. All right.